All right, I would like to welcome the next speaker to the stage. Okay.
Yeah, that's right. Hi, good afternoon, everyone. The lunch break is right around the corner, so I hope the caffeine is starting to kick in for the last bit. My name is Rosalie Maas. I'm one of the co-founders of Bird'sAI. And what we do is we are working to automate the analysis of Earth observation data to really lower the threshold of the use of actionable data for organizations that are not necessarily tech-oriented for large-scale and high-frequency use. Of course, using AI. Before I dive right in, I would like to start with posing this question. I don't expect you to answer it right away, but I would like you to mull it over in your head. So given the possibility to monitor anything that is visible from space, what would it be? What would you track? What would you build a database on? Right. So about Bird'sAI, what we aim for is helping organizations work more data-driven in a very basic sense. The reason why we do this is because we believe that for better, more actionable information on spatial dynamics can help people make more informed and also more sustainable land use and land management decisions. Because what is true for business for us is also true for sustainable land management, and that is what gets monitored, gets managed. So how we do this? The way we do this is by providing dedicated spatial data for your specific monitoring challenge as any organization. So you have the opportunity to, well, firstly, make more comprehensive risk analyses, make better area-specific impact assessments, and to monitor compliance to location-bound agreements and policies. For quite obvious reasons, this is interesting to governments, to NGOs, international organizations, but it's also interesting for example, larger food companies with a huge supply chain abroad, or for the financial sector when you want to do, well, the risk analysis is pretty much what they do, but also when they, for example, lend to a customer overseas to see whether certain location-bound agreements are actually adhered to. So for various organizations and purposes, this is very interesting information. So what does this look like? How do we really enable organizations to work in a more data-driven way by providing them dedicated information for their monitoring challenge? It looks like a dedicated satellite-based system for continuous monitoring of land use and land cover. Equipped with AI technology for automated analysis, because pretty much all of yesterday has been on this. I'm not going to be a broken record, but the headline is there's too much data for human eyes to go over, so the next best thing, and in some cases even better, is a human brain or a computer brain to look at it. So that is why we use this, and it's also great for large-scale and high-frequency analysis. Secondly, it's equipped with an API to query for the needed information, because when, for example, we start monitoring infrastructure in India, or when we start monitoring subsistence farming in Ghana, or whatever is visible from space, you build up a database that you then want to query, because to make information truly actionable, you firstly need the information that you needed to make decisions on, but you also always need your own metrics. For example, if certain activities are illegal, it is never that any, for example, deforestation is illegal, but it's illegal in certain circumstances. And you always need to put your satellite data, or your satellite intelligence rather, next to your own metrics. Then thirdly, and this is really great for organizations that are not very tech savvy, and that is the dynamic map with analysis window. So basically our analysis pipeline goes from a raw satellite image all the way to a dynamic map that allows you to do basic analyses with this, aside from or together with the API. So you always get both. So this is just an example on deforestation, because this really makes you get a quick overview. So what you see in the background is, of course, the raw satellite image. On top of that is the per pixel classification. We only do per pixel classifications. In the light green highlighting, so all the forest is being detected, and then you see a difference in the year 2017 and 2018. What is nice to note here is that it's not only like the larger deforested area that is being detected, but it's also the infrastructure that is being built. And this is pretty great, because for those of you who have done something with deforestation, when a road is being built, that is a sure sign for future deforestation. So this actually enables local governments of local NGOs to act before something may go wrong. But maybe this is legal, but maybe it's not. So what makes us unique? Because, of course, this is Earth observation, and it's been around for decades. So the way we are unique is actually because none of us are from the remote sensing space originally. We are data scientists, software architects, mathematicians, and therefore we like to think that we look at the data with fresh eyes. And we break with sort of the mainstream in analysis right now by always making clever use of computing power to solve monitoring challenges. And this is, on the one hand, sort of a weakness because we would honestly not know what else to do with it. But on the other hand, it's also a strength because it allows you to really draw out all the information that is in an image. For example, instead of making a classification or drawing a conclusion about one pixel by taking 1 or 3 or 2 spectral bands and make a calculation and draw your conclusion, we take all the values, and not only all the values of, for example, Sentinel-2, but also Sentinel-1, and not only all the values of that one pixel, but also all the values of all the surrounding pixels. So a lot more information. And you simply let the computer crunch the numbers and it'll solve your problem. Secondly, and definitely related to this, is realizing always uniform and scalable solutions to monitoring challenges. Because to us, if something is visible from space on, for example, Sentinel data, the solution is the same. You use the exact same analysis pipeline, and therefore, whether we are looking at greenhouses or at infrastructure or at subsistence farming or at rice fields, it's all the same challenge to us. And because you have a uniform and scalable pipeline, you can also push for automated IT processes, like all the pushing around of data, all the augmenting of data can all be automated because when you have one process, it goes really fast. What also makes us unique is because our approach has not been possible for a very long time. This depends on a few things. Firstly, of course, there needs to be computer power that is sufficient, and the GPU has become more widely available, so we make use of that. Of course, you also need a good, reliable, and large-scale data source, and of course, with the Copernicus mission, that is covered as well. We also make use of TensorFlow, the AI software, and a stable, good, user-friendly API. So shout out to Synergize that we are currently using. So that together, so the data, the software, and the hardware, together with our machine learning and data science expertise, pack that together, and you have the automated monitoring solutions that you're looking for. This is all nice and great, but I would like to sort of mention how this is meaningful to users. Because what does this mean for someone who can use some sort of spatial data to really improve their organizational processes? And it basically comes down to being able to get dedicated spatial information on any subject, at any scale, at any possible frequency, as well as having the flexibility to change your mind about all of the above. If you, for example, first want to monitor infrastructure in place A, you can later monitor infrastructure in place B. You cannot do it every month, but for example, every week. You can add classes, subtract classes. You have a lot more flexibility because the entire monitoring system works very uniformly. So maybe it's kind of counterintuitive to marry uniformity and scalability to flexibility. But because to us, every challenge is basically a computer vision challenge, the solutions are very similar. So now I would like to go through a video. Hopefully it works. I'm showing these logos because we did the first project that I will show on deforestation in the Chaco region together with IUCN and Gira Paraguay. So credits there. Yeah, so I guess it's going to play right away. So what you're going to see here is a piece of the Chaco area. In the background, you see a world map. This is simply for knowing where you are. On top of that is the satellite imagery, and the green stuff is the forest classification. When I click out the layer, you see that it's very nicely picking out all the forest per pixel. So scrolling sort of over the map right now, you see that everything is classified very nicely, and that also the infrastructure is becoming visible. This is, by the way, a very typical way of what it looks like to do agriculture in that forest area. So zooming out a bit, I'm showing you some more of the map. I'd like to zoom into an area where there's been a quite clear change over time. That is this area. You also saw it in the picture before, but now you can also see it like in real time, as well as the non-classification picture. So here you see the difference. It is about 9 months difference, and this is just the satellite imagery. It's a mosaic to get rid of the clouds, because clouds are a thing. And then this is the classification again. As said, this is just one example, so I'll also go over some other examples. And here we find ourselves in the Netherlands. And what you're seeing here is, again, the world map for knowing where you are purposes. This is the satellite data, and that is the classification. And you also see that all the satellite imagery is really cropped to the agricultural fields only, because that's what we're interested in here. And the classification is on the management type of that agricultural land. So that is, again, a monitoring challenge that is very nicely done from space, because it's visible from space. And it's something you want to know about on a continuous basis. Wow, this is a very hazy day in Pakistan, Islamabad. The red stuff you're seeing is a highlight of residential area, and it goes to show that you can not only monitor vegetation, but also human-made things. This is Greenland, and this is a model that is automatically detecting ice-covered landmass. That is just to show you a few examples of the things that are possible, but of course I asked you to think of that list of things that you would like to monitor through time, that you would like a database on, that you would like to communicate with your partners, your customers, something for your research. So I would like to go back to that question. Given the possibility to monitor anything that is visible from space, what would it be? Because it is truly at our fingertips. With a combination of data that we have, software that we have, intelligence that we have, and computing power that we have, has become a reality for us. So to remember, we are Bird'sAI, and of course, we are here to connect. So if this gave you any ideas for yourself, your partners, customers, for us, please come find us. We're here right in the front, and we'll be here the rest of the day, and I will be on the other end of these contact details for a whole lot longer. So thank you very much.
Okay, we have time for